Hello everyone, and welcome to the first installment of my new YouTube channel. This is tentatively titled. So today I'm going to be taking apart the Kaba Simplex 900, I believe it is. This is a push-button style lock. The operation of this lock is pretty straightforward. There are buttons on the front face here, 5 of them, and you can push them. When it's installed on the door, there's that cover plate, so it indicates the number of the button. So you can write down a combination that kind of makes sense. And then there's this dial here that you use to turn and open and close, open the lock or reset it when you're putting in a combination. So to give you a quick idea of how this lock works, I'll put in the combination. The combination right now is 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. And then I turn it in the direction of the arrow to engage the lock. Well, I can reset it to extend the bolt, and then I type in the combination. I can retract the bolt. That's the operation of the deadbolt style. To be honest, it's the one I'm less familiar with. I'm typically used to the one with the normal door latch type, and I'll probably include a picture of that somewhere around here so you can see what that looks like, but it's basically the same thing. So basically what I want to do with you today is take apart the lock and then explain how some of the internal mechanisms work, and maybe some of the design choices and whatever. There's a whole lot to this lock. Personally, I consider it one of my favorite locks, and genuinely, it is a beautiful, beautiful work of engineering. I'm totally in love with this lock. It's not the most secure, it's not impervious to attack, it's definitely got its problems, but mechanically it is a really well put together piece, so I think it's worth appreciating like that. I do have another lock. You can see some of the internals. That's kind of what the inside of that looks like. But I have another exact model of this that I entirely disassembled down to its bare parts, basically. I'll probably do that in a follow-up video. And if you're looking at how to get the combination by taking apart the lock, Kaba themselves have put out literature on that. I'll show you how to do that here. But I'm going to do another video to follow this up that will show you how to get the combination without actually having access to the lock itself. The way that Kaba shows it, you need to be on the inside of the door so that you can remove it from the door. I'll show you how you can actually attack the lock, but that's in a later video. Today we're just going to take it apart. So disassembly, pretty straightforward. So this is sort of how it would look from the side. The door would obviously be here. There's a few more pieces to mount it to the door and all of that. That's not super worth getting into here. So I'm just going to show you how it goes. You would unscrew it from the door. It's got 3 screws to mount the main casting. And then you would pull it out, and that would basically separate it from this faceplate. This faceplate is just a piece of stamped brass, and not really much to it. There's a few other pieces that would go in there to sort of reinforce the door, provide a surface for this to sit on, all that. None of that's particularly interesting, so we're kind of just going to skip it today. So I'm going to get a flathead screwdriver, and I'll actually start by taking off this cover plate. Sorry if my camera works a little shoddy. I'm pretty new to making YouTube videos. So there's a screw there. Sheet metal. Yeah, let me get that in the frame. It's not liking to focus. There we go. Split point. It's a kind of standard self-drilling sheet metal screw. Honestly, I'm not super sure why they put that in here. Maybe they don't actually drill, and well, obviously they're drilling the hole, but maybe they're not tapping the hole when they're making the casting. Probably going to talk a lot about how this lock is made. Definitely will in the full teardown video. So if that's your thing, wait for that. Don't think we can pop this off yet. No, we can't. So there's these screws with these little tabs that are holding on this push button assembly, we'll call it. There's not really a ton of words for these things. And I will probably be calling things by the wrong name. I have my own terminology that I've developed through the years explaining this and other locks. And I do like to use sort of more universal terms when I'm talking about this, just so that it makes more sense with, you know, other locks, and I can sort of draw parallels between them. So take off this assembly. You can see these little tabs that just hold it on. Those can go off to the side. And then we have this piece. So this is the first major sub-assembly. What this is basically it converts this pentagon pattern into linear input. So if I push 1, you'll see that first one come up. If I push 2, you'll actually see the third one come up. 3 is the fourth, 4 is the fifth, and then 5 actually does the second one. It's just sort of the arrangement of the pins. Kind of dictates that they go in a weird order. And so what that's doing is it's pushing on these tabs down here. Ooh, there's a little wood in there, I think, from a door. So it's pushing on these on these tabs, which are actually how, we'll call it the code block, takes its input. So all this is just an interface. It's a way of communicating that information into the internal code block. So before we pop that out, let's pop this cover off. Well, let's not skip too far. We have this little rack and pinion style thing. That's apparently spring-loaded. Oh, that's neat. So what that is it's spring-loaded, so it always wants to be towards one side or the other. We'll call that bistable. Fairly common feature to have in deadbolts and deadbolt-like assemblies. So you see how it just snaps back and forth between that. The normal door lock version doesn't have that spring. It just sort of smoothly slides back and forth between them. But basically, this gear is going to be pushing on this deadbolt and pushing it in and out. I will probably include a small follow-up explaining this part a little more in the more typical door latch assembly, because that's really cool, and it's got a little bit extra going on there with a dead latch and all of that. Unfortunately, that's not going on here, but you get to see something else a little more simple, perhaps. This threaded rod, or this keyed shaft, we'll call it. You can see that key in each side of it. That just goes to this tab on the back, and that's how you toggle the state of the door from the inside. So you can't really see it, but there are sort of dents in that shaft that grip onto that key, and it couples them together mechanically. So we can just pull this whole piece out. Probably shouldn't have done that. There's a little ball for detent, and what's catching on is definitely the spring that held that ball in. That just helps it roll a little more smoothly. Let's see if I can get that out. Okay, yeah, so that's just a little spring, sits in that pocket, and it preloads the ball up. Apparently there's another one here. That just helps it roll, slide, and stay a little more smooth. So get down to the more interesting part, which is this whole code block. If you're wondering what this is how information goes into the lock, or how this shaft couples into that code block. So I'm going to grab the shaft off for a second. Okay, so I didn't really get the shaft off. I actually grabbed that latch from a different lock. You can tell it's a different color. No big deal. The other one's just kind of frozen on. Apparently it's a Navy surplus lock, so you can definitely see some of that salty air kind of damage that it does. But if you look up there, maybe you can see that keying. You can definitely see the punching in on the side. And that merges with that key there. Well, it rather merges with this keyed shaft, which goes through the door, and that keyed shaft has the same shape in the back, so we can functionally use it the same way here. And that's going to move it in and out. You see that's the sort of reset or lock position in this case. And so when that pulls back, it's going to pull on that arm and cause this internal mechanism to toggle, and that's going to cause that to flip and push the bolt out. So this part here sits inside that area and sits inside this groove, and we'll pull it in and out as it toggles between states. Again, that works a little differently in the door latch case. I'll show that in another video, hopefully a quick one. But the principle is basically the same. If it goes in one direction, in this direction, that shaft slides cleanly through it, nothing happens. If it goes in the other direction, it pulls on that shaft and toggles the state of the door, or I guess extends the bolt. So I'll pull that off, and then I'll get this code block out. And right now I'm not sure if it shows up on the video, but there's some text down there. It says 3-03. Don't know what that is, but if I had to take a guess, it's the month and year that the lock was manufactured, so March 2003. Yeah. This code block was apparently made in December of 2003, so it's possible that that stamping is a year, and maybe that's a machine or something, or maybe this part was just made a lot earlier in the year. I don't know. These screws are, for some reason, pointy ones. I've taken apart a lot of these locks, and it's always the same ordering or configuration of the screws, and I never really know why. We're going to get into the code block now, and there's just one more thing I want to show you before we break that open. So this right here, this whole main body is just a casting, and it's painted that sort of brass color, but it is not sure what that is. Maybe aluminum, maybe that's a steel. It's got kind of a weird sound to it. It might be galvanized steel, but it's a whole lock assembly, and then there's this at the top. So if you unscrew that, which unfortunately I don't think I have a bit large enough to do, but maybe, oh, almost certainly not. But if you were to unscrew that, then there would just be a hole clean into the lock. That hole is what you use to change the combination of the lock, and I'll show you how that mechanism works too, and that is really ingenious. So the one thing that makes this lock really interesting to me is that not only can you push single buttons, but you can also push two buttons at the same time, and that is different than pushing one then the other, or the other and then the first. You can do that with 3, 4, all 5. Those are all unique, different presses, and this lock does enforce order in the pressing. So if you push 1 then 2, that is different than pushing 2 then 1. If you're familiar with things like the master lock key safe or things like that, those are the big plastic boxes that you see hanging on the front doors of homes that are being sold. They're commonly used in real estate, and they hold a key inside. Those will often have these push buttons, and those are actually, in the true sense, combinations. In the mathematical sense, it doesn't matter which order you put them in, versus this, which is a permutation. Order matters. That gives you a lot more unique combinations, and it makes the lock a lot more secure. The other kind are prone to wearing and marking, and once you know which digits go in that combination, it's super easy to figure out what it is, because that's all that matters. So I'm just going to pop off this sheet metal casing. That came off pretty painlessly, but if you look on the back, it's just held in sort of with friction and clipping on these tabs. So this is the heart and soul of the lock, and this is kind of how it all works. It's always a little hard to know where to start with this, but I'm going to start from the buttons in the front. So if we push these buttons, you'll see some parts start turning, and you'll see these springs start to give as I push the button. And when I push it all the way, you hear a little click, and the spring stays permanently elongated. So that spring's attached to a little tab. Oops, sorry. The spring's attached to a little tab. So that button pushes on that tab and toggles it to a new position. I'm gonna attach my little turner here, my little latch, and I'm gonna reset the lock back to its original position. And now you see all the springs are lined up again. So what these tabs look like inside is like this. That sort of long leg is there for alignment. The flat portion is the part that's doing the pushing. And let me grab you one of the, well, you can see one of these latches that's sort of pushing against. That hook there on this side is what the spring hooks into, and then it hooks onto this aluminum bent sheet metal. And that sort of indent over here, that indent over here is what that tab pushes on. And then it's got this extra little leg that pushes on this gear over here. We're going to talk about what those gears do and why they're important and how that mechanism works. But the short version is whenever we push a button, it causes that latch to kick, and that latch causes that gear to rotate. And that's going to be basically the essential functioning of how this lock works. So again, it's totally reset now. So let's look over here at what's happening when we push the buttons. Sorry, my camera's a little shaky. So as I push that button, you can see that wheel rotate. I'll reset it. So I start to push it, and the wheel rotates a little bit. And I push it all the way in, and it rotates fully, and it stays locked. If I push it a little bit and I let go, it snaps back. So that's me starting to push on that latch, and then that little bit is it actually turning another gear. How that mechanism works is really interesting, and basically is how we enforce order. But this right here you can see already pushes the wheels. So you can imagine a world in which some of the wheels are already lined up, some of the wheels are just one off, and you just push them once and they turn. Now, it's not how this works. This lock enforces order. So when we push that once, now it's in the correct position. So let's try pushing another button. And that other wheel rotated, but so did the first one. And so that's really interesting. What that means is that this one gets rotated every time we push a button. In fact, every button that's been pushed will rotate every time a subsequent button is pushed. And you can see if we push two buttons at once, they both will rotate together. So when something's one off like that, it actually means it's the last button to be pressed. So we want to look at the button that's the furthest out, which I think is probably this. No, that's, yeah. So it should be 1, 2, 3. You can see them, all those gates lining up. And the fourth one doesn't quite line up because it has to do that initial rotation first. And now it's lined up with the rest of them. That's 4 and then 5. So now this plate has all these fingers that line up with the gates in what we call the code gears. Or I will sometimes call them tumblers. Sort of more similar to some other locks and how those work. But these gates and these fingers all have to line up So when I go to turn this latch, it pushes those fingers up and they go into the gates. If those weren't there, they would hit. So when I push it all the way through, what actually happens is they go all the way up, it snaps back, and then it engages the resetting mechanism. So you can't push it twice in a row. But now when I push it, you see that those fingers hit the wheels. And so that's basically how it checks whether or not you have the right combination. And that mechanism where every wheel gets turned with every wheel that got pushed before it, that's how we enforce order. Now, if you take it apart and you look at it like this is actually exactly how you get the combination back out. You look for whichever one's the farthest away, and then which one's the second farthest, third farthest, etc., until you have the whole combination. Remembering that sometimes things can be pushed together at the same time. We'll call those double or triple presses, or quadruple or quintuple. But you basically never see more than a triple press, even those are a little rare. So how is it actually accomplishing this? Well, there's these intermediary driving gears, is what I like to call them, that are coupling these code gears to what we call, I'm going to call this the gear shaft. So this whole shaft, it's hard to see here, but thankfully I have a spare, has geared teeth all the way along it. The portion at the top is actually for manufacturing purposes. It doesn't serve any functionality to the lock itself. And then this bottom piece is kind of D-shaped, and that's a little of how the resetting mechanism works. But as far as enforcing the code goes, you just have these geared cut sections like this. And it's a quarter of a shaft or a third of a shaft. Then this is what the code wheels look like, sort of by themselves. And so you see that gate, where they all line up. And, well, I just dropped a piece. I'm going to show you the other type of wheel, which is a little harder to get out. So this is that sort of drive wheel, or that idler wheel that I was talking about. Let's get a good shot of that. All right, so you can see that that is mostly geared, but there's some portion that has no teeth, and that's really important for how this lock works. There's that little notch. That's actually where that plate sits in. So there's a tooth that sits in here, and when you push the button for the first time, that tooth pushes on the gear, and then it leaves the gear. So now it's actually resting against it, sort of like that. And that will prevent, well, it basically decouples the tooth from the gear, but it gives that gear its first turn. So when that gear does its first turn, it's basically sitting like this with respect to the code gear, or with respect to the shaft. So when the gear does its first turn, it's sitting like this with respect to the shaft. So what happens when it does that turn, we'll do that one step down, is now, well, we can do that at the top. All right. I'm a little indecisive today. When it does that turn, these teeth start to mesh for the first time, and it turns a little farther. And that causes this shaft to rotate a little bit. And now when this shaft rotates, it also drives that gear. Now, this this driving gear also interfaces with the code gears. So let me pull one of those out. So those just link together like that. They also have matching teeth, and when it rotates, it turns the code gear. All right. So when you put that all together, what happens is we push on the button. The button causes this gear to rotate. That gear turns this gear, this whole gear shaft. Now, when the gear shaft is turning, it has all of these tooth sections, and so every gear that turns will engage its drive gear into this gear shaft. And whenever its drive gear turns, it also turns its code gear. So once a button has been pressed once, its drive gear rotates enough that it is now coupled into this gear shaft. And whenever the gear shaft turns, it also turns the drive gear. So basically, pressing a button once links it to the shaft and means that every subsequent press, which also turns the shaft, turns every gear that's coupled to it. That can be a little confusing, but hopefully you get the point. Now, if you want to see that a little more together, watch these drive gears, and we'll watch this gear shaft. As I push the button, you can see that starts to rotate, but the drive shaft isn't turning yet. So that's just the first tooth meeting up with the drive shaft. And then when I click all the way, you see the drive shaft kick a little bit. It's only turning maybe 1 or 2 teeth worth. Then when I push the next one, you can again see it's turning, but it's not engaged yet. And then when it finally clicks, it turns that drive shaft. Now, if you're wondering what's keeping the drive shaft turning smoothly, there's also an answer to that. It's this little piece down here. That's just sprung against the drive shaft, and this little hook engages with the teeth just like that, and just provides sort of I'll show it like that. Just provides a little bit of resistance and sort of a natural settling point at every position along the gear. Actually, I think it's more like that. I think it's got that orientation, but it just wants to sit at the root of every gear, so that sort of keeps it all together, and keeps it in fixed positions and keeps it from sort of rotating on its own. Okay, so what I want to show you here is how the double presses work. I already talked about how the single presses work. Hopefully this will be kind of clear. The first time I tried to film this, it wound up an incoherent mess. I was using my fingers as gears and all that. Hopefully now at least we have a coherent mess. So what we have here is the code gear, the drive gear, and then we have the drive shaft that links all of the drive gears which have been pressed. So the code gear would sit somewhere out here, and that would be being turned by the drive gear. We don't super need to pay attention to that right now. We know that whenever the code gear turns, or whenever the drive gear turns, it means the code gear turns basically the same amount. So we can just use the drive gear here as the analog for the code gear as well. So I talked before about how there's sort of 2 stages to button pressing. There's that first soft stage where you push a little bit and you feel very little resistance. It's very springy. And then you push harder and you get sort of this hard click. So I want to explain a little bit of what's going on there. So I showed you before, there's this little piece. This is sort of a retention piece. So there's a spring that sits right here, and this spiky tooth part actually sits in the drive gear in one of these teeth. Probably up here, I guess. And it sits further along the shaft. So in that first stage of the press, we're turning the drive gear, and it's moving, just like this. And that's while that tab that we saw earlier is still engaged into the code or into the drive gear. So the spring will still push it in both directions. We push a little bit, it'll still spring back. Once we hit this position though, we have for the first time contact between the teeth of our drive gear and of the drive shaft. Now, this is the point where that sort of soft push ends, and we are right before that hard click stage. So if you can imagine something, let's, as a demonstration, use the head of this other screwdriver. That's sitting in the teeth of the code or of the drive shaft, and so it resists the drive shaft moving, but it's still got some give, so it can pop out. It can sort of fold out of the way when that drive shaft moves. So this is what's preventing the drive shaft from rotating, and when we push harder, we reach that point where it pops out, and because it wants to go back in, it pops in again in a new position. And that's providing that resistance, and that's where that click comes from. Now, this is sort of an important point. I'm going to get rid of my retention device for simplicity's sake. Guess I could have made a better mock-up, but I want to explain how this relates to the double pressing. So when you double press, there's a point where you're pushing, and you first make contact between the two gears. Now what's important about this stage is, if we keep turning the drive gear, you can see that that drive shaft also turns with it, right? And that makes sense. That's exactly what was happening with the single press. But the other thing that's important is, once we reach this position, the drive shaft can also turn the drive gear. Works even better if you don't cut your gears out of cardboard. So in this position, I'll set it up again. We can turn with our drive shaft, or with our drive gear, or we can drive from our drive shaft and push it. And the way that this relates to the double pressing is, because there's that resistance, when you push on two buttons at the same time, those two drive gears will move very easily. And so both of them will wind up in this position. Now, if you push harder, one of them turns the drive shaft. And at the exact same time, the other one is being driven by the drive shaft. So this forces them to link. Once a gear is pushed into this position, then when the drive shaft moves, the gear will move as well. Hopefully, I've set up my model right, and I can show you that for different two positions, this still winds up being exactly the case that we get. So even if you already pushed the button once or twice before, or other buttons, and that drive shaft has already turned, you can still get to this initial first tooth contact state. That's actually a little hard to pull off, but if your gears are spaced right, it should work. It's just a matter of selecting the right tooth geometry. So what happens is, we have that soft press, we have first engagement, and now either gear can push the drive shaft, and the drive shaft will push the remaining gear. The same exact thing happens for double and for triple, quadruple, even quintuple presses. It's the same mechanism. All of them are reaching this primed position, and then one is doing the driving, and the others are being pushed. You can in fact start to push and alternate or anything like that, although it's pretty hard with the retention device. It sort of likes to snap between legal states. But in essence, that's exactly how, that's all it takes to make the double press work. And to me, this is actually one of the more brilliant mechanisms of how the lock works. By adding the ability to put in 2 or 3 presses at a single time, they're greatly increasing the number of combinations you can have in a lock, and sort of scrambling up your options a lot. And that mechanism doesn't work without each one of these parts. You need that partially toothed gear, you need the drive shaft, and you need that retention device. If you don't have the retention device holding the drive shaft in certain particular positions, then you don't have the resistance that forces things to get linked, and you'd wind up with teeth colliding, or one would move in front of the other, and you would wind up doing one press and then another press instead of a double press. So all of those components are essential to making it work. Okay, so hopefully now you have an understanding of how putting in the combination works. Now let's take a look at how changing the combination works. So I showed you before that there's this button at the top of the lock, or this hole, if I take this screw out. Now what the hole lets you push is right here. We're going to call this the button. You can see it's sort of there's a shaft that sits on top of this other, well, there's a plate that sits on top of this shaft. And that shaft is what all of the code gears are linked to. Now, the way that you change the combination is you type in the old combination, you push the button, then you clear the lock by rotating in one direction, you type in your new combination, and then you unlock the lock. You turn it in the unlock direction. So why does that work, and how does that work? Well, let me show you. So let me type in the old combination. 1, 2, 3, 4, 5. So now all of these code gears have their gates lined up with the fingers of the plate. I'm going to push on that button just like I would from the outside. And it's going to slide all of these code gears down. So now they're locked into the fingers of the plate. But the important thing is that whole shaft slid down. The plate didn't slide up. So if you look over here, you can kind of see that there's the code gears in there, but they're now offset enough that they no longer link up with the drive gears. So this means that if we were to push those buttons again, we already pushed all of them, but if we were to push them again, we wouldn't actually cause any of the drive gears to rotate, and we wouldn't cause the shaft to rotate. So the next step in setting the combination is to clear the combination. Let's hope I'm turning this in the right direction. Okay, I am. And now, having cleared the combination, everything's back to its neutral state. All of these code gear or drive gears are back to their original position. The drive shaft is back in its original position. Everything is where it ought to be. And this is as if you hadn't pushed any buttons in lock at all. So now, if you look over here, you can also tell that none of the springs are stretched, which means we are free to push buttons again. So if I set the combination to, let's say 15, and then I'm going to push this one, which is 2, but I want you to see the front. So it's already done its rotation, and then it rotates again. So note that the drive gear is what's taking the input, and it's transferring it to both the drive shaft and the code gear. So it goes drive gear, drive shaft, or drive gear to code gear and drive shaft, and the drive shaft sometimes to the other drive shaft or the drive gears and then their code gears. So when I pushed that button, it turned everything, but none of these have rotated their drive or their code gears because they can't. They're not linked to them. So now when I go to set the combination, let me get my key here so it's a little smoother. You're going to see it's going to push that plate up, and because it pushed it up, now the code gears and the drive gears got linked again. So now they're coupled into each other. So whatever position that the drive gears had after I typed in the new combo got set, and then everything got returned to its neutral position, which meant turning back the drive gears, and as a consequence caused the code gears to rotate as well. If that doesn't make sense, sort of go back and watch it again, leave a bunch of comments, and I'll take a look at it. It's a bit of a hard thing to explain, but you can now see that when I press 1 and 2, you can see that those two line up. And if I press them both at the same time, they rotate. Now they're more in line with, well, that's 1 and 5. Now they're more in line with 2, and when I push 2, they're all together. And now that all lines up. So one more time, if I want to change the combination, push it down, take my latch here, and I reset it, and that all resets. And then I'm going to set my combination as just 1. It's going to rotate that. And I'm going to set it again, and you're going to see that, hopefully you can see both sides of that. It's going to push up those code gears, and then I'm going to reset everything. So it relinks, and then it resets. And so doing this causes the code gears to decouple. Then I'm changing the state of these drive gears. And then I'm recoupling them to the code gears so that whatever offset I introduced into the drive gears now becomes introduced into the code gears, and the drive gears go back to their neutral position. So that's it for right now. Apologize for some of the shoddy camera work. I'm going to be doing a follow-up video to this, maybe a short one just to show the difference between the deadbolt and the actual door latch. I have another lock in a box. Unfortunately, that box is currently my camera stand. And then I also have this lock that I sort of tore apart. You can look at some of the internals, how the lock is made, what all those parts are, and I'll probably talk a little about how this lock is put together, how these parts are manufactured, or how I think they're manufactured, and sort of the why and the how there. And I'm going to do one on how we actually decode it from the outside. So basically, what if all you have access to is basically just this, your buttons, and then your latch? How can you get the combination out of that? The attack is really interesting. It's somewhat complicated, and it's got some parallels to lockpicking and some parallels to safe cracking. I'll talk more about that, but we're going to use a method that we call the tentative method, which is what I've named this channel after. So stay tuned. If you have any more questions or comments, please leave those in the below the video. And if you want to see any other locks taken apart, explained, stuff like that, I'd love more suggestions for videos to do, so leave those in the comments below as well. There's one more neat trick that I want to show you, and I call this a half press. I'm not sure if that's a term that other people use. It's a term that's been used around people I know. We used to have these in our dorms. And it's a trick that's not super common. So I'm going to change the combination one more time. I'm going to press 1, and I push down on this, and then I'm going to clear it. And then I'm going to push, let's say 1, 5, and then before I do 2, so you can see how I can push that partially, and I haven't clicked it yet. When you look, you can see that gear rotate, just like we saw before. It does a little rotation, but it doesn't click yet. So if I can actually push that partially, and then while holding that, I can enter the combination. And what that will do is it will basically store the position as a slight offset rather than a full press. So now I do 1, 5, and you notice I can't put in the combination because it just doesn't line up there. That finger for 3, it just doesn't line up. So when I push just a little bit, now it does, and now I can enter the combination. So that's what I call a half press, and I can show you that if I push 1 and then 5 and then I push 3 completely, everything overshoots. 3 itself overshoots. You can definitely see that bit over there, and the other ones also overshoot because they've now been rotated 3 times. Well, 1's been rotated 3 times, 2's been rotated twice instead of twice and once like they want to be. So that's a sort of a little known trick that I like to show people. And the important part is because of the way it's put in, because it's only a gentle press and you have to hold it while you're entering, you can't use that anywhere in the combination except as the very last digit. But it's a really cool trick. You can also do it as a double half press, which is different than a single press. But you can't merge it with another press because of the way that we talked about the mechanics of how the double pressing actually works. So you could do 3 of them at a time if you wanted. You can do any number of them. You could do all 5. But you just can't merge it with any full presses, and it has to go last.